Minimum domino rotations for equal rows. So to solve this problem, we only need to know one concept, and those are arrays. Arrays are simply data structures that store values in a fixed length. So 1, 2, 3, for example, is an array. And we use this to solve the problem. And to do it, let's first crunch out the logic, right? We have the top faces, 2, 1, 2, 4, 2, 2, and the bottom faces, 5, 2, 6, 2, 3, 2. We have one of two possibilities. One, we get all the top faces to be the same, or two, we get all the bottom faces to be the same. So let's first consider this case by case, right? For the top, to get all the top faces to be the same, what possible values can that face be? Well, it's dictated by the faces of the first domino. Because the criteria is all faces of the domino, whether it's top or bottom, have to be the same value. So those values, therefore, must include the first domino. If the first domino doesn't even include the values, then the other dominoes can't include it either. Therefore, the only possible values that this criteria can be met on are 2 and 5. So let's consider a case by case. Let's consider the value 2, and for us flipping all dominoes until the top faces are the same. So the first domino, well, it's already a 2, right? The top face is already a 2, so we do nothing. But what about the second domino? The second domino, we need to flip it. So the count, right, is going to be +1. And what about for the third domino? It's already the same. The fourth domino needs to be flipped, and the fifth and sixth dominoes are the same, so our count is 2. How many flips do we need to get the bottom faces to be the same? Well, the bottom face needs to be a 2, so we got to flip it once, right, to get the 2 to the bottom, and the second domino is already good. The third domino needs to be flipped, and the fourth domino can stay the same, and the fifth domino have to be flipped. Of these two scenarios, getting the top values to be the same takes the least amount of flips. Therefore, our final value for the case of 2 is going to be 2. And you see where this goes. We do the same for 5, and actually, let's iterate through 5, right? Because 5 actually won't work. Let's say we do top for 5, right? And the top is going to be what? Well, we need to flip it once, but what about the second domino? There's no 5 to be found. So we immediately can say we can stop counting this case because it would never work since all dominoes do not share that common value. So with this, we can program it up in Python. Well, we said we're going to have top moves and bottom moves. And top moves represents the number of flips needed to get all the top values to be the same, and vice versa for the bottom. And what else do we need to know? We need to know the possible values to consider. So the values that are possible is going to be a set of a list. And the list is going to contain tops 0 and bottom 0. The reason for this, we use a set because there's a potential that the two values are the same. So for the very last domino in the example on the left here, you can see that the top and bottom values are the same. So we use a set to basically avoid redundant calculations. And now we can begin. So we can say for value in values, what can we say? We can say for I in range 0 to the length of tops, and tops and bottoms are the same length because they are part of the same domino. We can say what? If the top value at the current index is not equal to the value, and the bottom value of the current domino is not equal to the value, then we can immediately return negative. We can immediately break. The reason for this is because, well, the values don't match up. It's not a valid domino, like in the case of the 5 we saw previously. So that accounts for that case. But otherwise, we know there's a flip possible. So if top of I is not equal to value, then we have to flip to get the top value to be the same. Therefore, we're going to say top moves is equal to top moves plus 1. And the same goes for the bottom. If tops is TOPS. TOPS, BOTTOMS. If bottoms of I is not equal to value, then bottom moves have to be incremented by 1. And what can we say? If we never break in this entire for loop, that means we've successfully flipped all the dominoes to satisfy one of the two scenarios, actually both scenarios. Therefore, we can say if I is equal to the length of tops minus 1, then let's have a res array to store all the possible value results, to say res.append the min of top moves and bottom moves. That would be the solution for the given value. But what else do we need to know? We need to reset top and bottom moves, right, for every iteration. Because for every iteration, they're independent of each other, so we have to reset the counts. And with that, we're pretty much done. If the length of the result is equal to 0, that means nothing is possible, so we return -1. Otherwise, if the length of res is equal to 1, meaning there's only one solution, we return that solution. Otherwise, we return the minimum of the two possible solutions by doing return min of res 0 and res 1. And that should work. So let's submit, or rather run it first. And it passes all our test cases, so let's submit. And it passes everything. So that's the solution.